In the vastness of space lurks a killer. An asteroid on a collision course with the Earth. It's a 1,000,000 chance, but many believe it has happened before. 65 million years ago, an asteroid ended the dinosaurs' domination of the planet.
The whole globe reduced to ash is just scary.
Along with the dinosaurs, 70% of all living things on the planet died out.
That's not just a mass kill, it's a mass extinction.
And we may join the dinosaurs. In an instant, ancient history might be repeated.
The whole sky would have just become a red, glowing sheet of lava.
A blast hundreds of thousands of times larger than an atomic bomb.
The impact would be a catastrophe, a disaster that's absolutely unparalleled in human experience.
Millions of lives lost in just minutes.
It's more horrific than anything that we had previously imagined.
Are we doomed to face the same fate as the dinosaurs? Or can we stop it in time?
There is the ultimate threat of having our species extinguished by a huge monster asteroid coming in and hitting us.
Southern California is no stranger to natural disasters. The area's 20 million residents have endured earthquakes, mudslides, and firestorms. But the deadliest threat may come from the sky. Although its arrival would be no surprise, there would be nowhere to run. Los Angeles would be transformed from a city into a bullseye.
It's like a mountain running into the earth at the speed of a bullet.
The impact is larger than 1,000 Hiroshimas.
It's going to be a gigantic explosion and blindingly brilliant and far brighter than the sun.
The ensuing firestorm incinerates everything within a 100-mile radius. The massive pressures generate 300-mile-per-hour winds, flattening what's left. And the devastation continues.
All kinds of debris would fall on you, like being in Pompeii.
In 60 seconds, Beverly Hills, Los Angeles, Malibu are gone. Then the final assault. Monstrous tsunamis more than 500 feet high rampage across the Pacific.
Tsunami waves would propagate up and down the coast, all the way to the tip of Baja, to Alaska, and bigger than any waves known to man so far.
By the time it's over, millions up and down the west coast of America have been killed.
The impact would be a catastrophe, a disaster that's absolutely unparalleled in human experience.
We are living on borrowed time. This is what we can expect from an asteroid impact, if our luck doesn't hold out.
We're gradually appreciating the fact that the Earth does take hits fairly frequently.
At the moment, there are 180 known impact craters etched into the surface of the Earth. The half-mile Wolf Creek crater in Australia, the 60-mile Manicouagan crater in Canada, and a recently discovered 19-mile-wide crater in the Sahara Desert represent the billion-year legacy of collisions with asteroids. Left over from the creation of the solar system, asteroids are the orphans of the universe. Millions orbit in a distinct belt between Jupiter and Mars.
The asteroids are essentially the fossils of planetary formation, if you will. They are the small building block debris left over from the formation of the terrestrial planets.
They can reach lengths of 500 miles and fly through space at nearly 40,000 miles per hour.
These speeds are almost impossible to imagine, but if we were trying to explain that, imagine being in a plane moving at that speed. You could cross the continent from Los Angeles to New York City in just 3 or 4 minutes.
Any one of them could hit the Earth with devastating consequences.
Asteroids come around at random. It's like a Las Vegas shooting gallery.
Statistically, over time, we are more likely to die from an asteroid impact than from a tornado or tsunami. There is one reason for our good luck. Large asteroids rarely hit the Earth. The one that ended the age of the dinosaurs was 65 million years ago. Long before mammals, hundreds of species of these ancient animals, both large and small, roamed the globe. Pterosaurs sailed the skies. Ancient sharks ruled the seas. And the land was lush with a diversity of plants. Then, suddenly, nearly 3/4 of all living things were killed in one of the planet's worst mass extinctions. For years, scientists debated what caused the abrupt demise of the dinosaurs. But recent discoveries point to a killer asteroid that ended an era. The theory is a 6-mile-wide asteroid struck the Earth near Chicxulub, Mexico. It's as if a mountain twice the size of Mount Everest fell from the sky. It smashed into the ocean with the power of 190 billion tons of TNT and left a crater 110 miles wide and 5 miles deep.
This impacting asteroid came screaming at the Earth's surface in excess of 20,000 miles per hour. It would have appeared to you as if the sky was suddenly split by fire, because the incoming object, as it went through the Earth's atmosphere, would have ionized a tremendous amount of gas in the Earth's atmosphere and essentially glowed. It would have looked like the sky was on fire.
It hit the ocean just off the coast of Mexico.
Ocean layer is just like the paper on a Christmas gift. It just is gone in a second. In fact, it blew away that layer and dug 30 kilometers deeper. We're talking digging a hole in the rocks, 20 miles down. So it's a huge, catastrophic event.
It had an energy that's maybe 10 or 100,000 times more than all the energy in all the nuclear weapons on the Earth.
The resulting fireball, brighter than 1,000 suns, burned everything within 500 miles and reached beyond the Earth's atmosphere. A shockwave and tremendous air blast followed, creating winds exceeding 2,000 miles per hour.
That pressure pulse and that wind had the capacity to completely destroy any plants and animals within a region of several hundred miles.
The impact created tidal waves 150 feet tall, washing over much of southern North America.
It shook the Earth for 1,000 miles around, and that shaking created many secondary landslides in the ocean. And those secondary landslides also made tsunamis. So we have tsunamis from the impact, we have tsunamis from the secondary landslide.
So as if that wasn't enough, you also had this impact ejecta, this rocky debris ejected out of the crater, come crashing back down onto the landscape, burying plants and animals that may have survived. In some cases, this debris was several hundred feet thick.
The heat from impact caused trees to burst into flames. Wildfires devastated the landscape for hundreds of miles.
If you were an animal, you likely would have passed out as the atmosphere around you became so hot. You would have dropped unconscious.
The intense heat overwhelmed everything it touched.
Now, as bad as this seems, as destructive as it would have been to the local Gulf of Mexico region, devastating life, it's not responsible for the mass extinction event that occurred 65 million years ago.
It wasn't the explosion itself that wiped out all the dinosaurs.
This was a global catastrophe. A catastrophe at a level we haven't seen in the last 200 million years.
The initial devastation was limited to 600 miles from the blast zone. But most of the life on the planet was snuffed out. Why? A controversial new theory that attempts to answer that question also challenges our understanding of asteroids. And that understanding may mean the difference between life and death. Scientists believe that sooner or later a large asteroid will hit our planet with devastating results. Their best evidence to the devastation is the global disaster that led to the disappearance of the dinosaurs. 65 million years ago, dinosaurs ruled supreme. Then it appears an asteroid struck the Earth near Chicxulub, Mexico, and they suddenly vanished.
The impact happened in a matter of moments, and it changed the world literally overnight.
Experts are still investigating exactly how the asteroid caused a worldwide extinction. The results may hold the secret to our own survival.
It's a crime scene that is very cold. It happened 65.5 million years ago.
Up through the 1970s, volcanoes were the prime suspects. One of the greatest periods of volcanic activity occurred around the time of the dinosaurs' disappearance. It was thought that the volcanoes threw so much ash into the atmosphere that it shielded enough sunlight to dramatically cool the planet and to cause a mass extinction. In 1980, a new theory proposed that an asteroid impact, not volcanoes, caused the dramatic climate change that explains the extinction. But in each case, climate change didn't explain why certain species survived. The latest research, however, has spurred a new and controversial theory that debris ejected from Chicxulub created a worldwide inferno.
The thing that was devastating globally was this 2,000 or 3,000 cubic kilometers of rock blasted into orbit. About 90% of it would come back down on the Earth. And when it hits the upper atmosphere, that friction creates an enormous amount of heat.
The entire sky, instead of seeing little individual shooting stars, the whole sky would have just become a red, glowing sheet of lava.
For years, scientists thought this had happened only in the vicinity of the impact site. But the new theory proposes fires covered much of the planet and better explains why some species were extinguished and some survived.
The sky would have turned about 1,200 degrees, about that color, which is about the color of the elements in the broiler of your oven. It's hot enough that on the surface of the Earth below, it would have ignited fires. So you would have gotten fires everywhere around the entire planet. The whole globe reduced to ash is just scary.
The intense heat from the falling debris would destroy every living thing above ground.
Any large exposed animal would immediately suffer burns all over his body and die, just like if you crawled into a broiler.
The best chance for survival was to move underground, something only small animals could do.
If you don't actually have a hole in the ground, you're going to be burned alive.
These are parts of victims. These are bones of Triceratops and duck-billed dinosaurs and Tyrannosaurus rexes. Here is just one horn of a Triceratops, the famous horned dinosaur of the late Cretaceous. This is just a bony horned core. And we find these things all over the place in the end of the Cretaceous, the last several hundred feet of the Cretaceous layers of rocks.
The Cretaceous period, the age of the dinosaurs, ends abruptly at one of the most significant moments in our planet's history, known as the KT boundary. The KT boundary is shorthand for the Cretaceous Tertiary boundary, the dividing line between the age of dinosaurs and the age of mammals.
The Cretaceous period went from 145 million years ago and it ended with a bang with the asteroid striking Mexico at 65.51 million years ago.
Evidence of this geological dividing line can be found all over the world and in abundance on the plains of eastern Colorado.
That is the KT boundary. This 2-centimeter thick layer came out of the sky. The excavation of the crater blew fragments of rock from Mexico to Colorado 65.5 million years ago. And one of the biggest asteroid impacts this planet has ever seen. Microscopic evidence in the clay, particles of rock that are shocked. Their crystalline lattice has been crushed.
Analyzing sediment from the KT layer, we find the pieces of shocked quartz, evidence of a powerful collision, as well as remnants of the Earth's crust melted by the asteroid's impact. These unique findings suggest a borderline through which the dinosaurs did not pass.
This is a Triceratops vertebra. This bone was found about 4 meters below the KT boundary. And one of the amazing things about dinosaurs is you always find them below the KT boundary, the debris horizon from the asteroid impact. Dinosaurs disappear from the terrestrial landscapes after the KT boundary.
The lack of large dinosaur fossils above the KT boundary suggests just how the asteroid killed them off. These huge bones are typical of land animals found in the period before the Chicxulub impact. This is what's been found afterwards.
This is typical of the size of jaw bones that you find afterwards, and you don't find anything much larger than this. These were the things that crawled out from burrows. If you ask, what is it that was likely to have been sheltered underground or in the water at the time of this impact? It's mammals, turtles, lizards, snakes, alligators, crocodiles. It's an exact match for what made it through.
Additional fossil evidence suggests large land animals were not the only ones struggling to survive at the KT boundary.
We always hear about the dinosaurs. Big deal about the dinosaurs. The real cool stuff are the plants. Almost everything in these cabinets are plants that went extinct at the end of the Cretaceous period.
Where before the KT boundary there had been 50 or 70 species of plants growing here. In a site like this, which is only a few meters above the KT boundary, or only a few tens of thousands of years after the event, we're only finding 5 to 8 species.
That's not just a mass kill, it's a mass extinction.
Like the animals that survived the asteroid's impact, the plants that endured past the KT boundary were protected from the heat.
The one thing we can say about the plants that survived KT boundary is that they were plants that lived in swamps during the Cretaceous.
But millions of species of sea animals and plants were also killed, despite being protected from the heat by the ocean. Why? To complete that part of the puzzle, scientists point to more recent disasters. Ash clouds from volcanic eruptions like Pinatubo and Montserrat plunged the nearby areas into darkness. The Chicxulub impact likely had the same effect, but on a much larger scale.
12 hours after this starts, it'll become pitch black, and it'll probably stay pitch black for months. And pitch black means darker than a moonless night. There'd be, not even cats could see.
The cloud of debris would have reached the upper atmosphere, spread around the globe, blocking sunlight from the Earth's surface.
This type of asteroid would have contained several weight % sulfur. That sulfur, when vaporized and deposited in the Earth's atmosphere, would form what we call sulfate aerosols. These aerosols would have heated the upper atmosphere of the Earth while causing cooling at the surface of the Earth.
The extended night and global cooling would have killed much of the sea's plankton, the basic building block of the global food chain. Without this food source, much of life in the sea would have starved to death.
That, in my mind, is the most probable explanation of the extinctions in the oceans.
The combination of the heat blast, fires, and ash cloud devastated life across the globe, all from a single asteroid impact. Based on what happened to the dinosaurs, many scientists believe another significant asteroid impact could exterminate the human race. That's why astronomers are scanning the skies, hoping to find an asteroid in time and protect us from the same fate as the dinosaurs. If an asteroid were headed toward Earth, depending on its size and position in the sky, we might not see it until it was too late. Asteroids entering our atmosphere are commonplace, and their beauty hides their underlying danger. Known as meteors as they impact our atmosphere, and meteorites when they reach the Earth's surface, asteroids near our planet range in size from tens of miles to a few inches across. These meteors are flying through the air just 50,000 feet away. That's closer to us than military spy planes, and just a little higher than commercial jets. On a planetary scale, that's a razor-thin margin, and they are moving at nearly 40,000 miles per hour, 40 times faster than a speeding bullet. As the evidence grows that a killer asteroid could destroy our planet, the need to protect ourselves from asteroid impacts has become a priority. In 1995, the United States Congress commissioned SpaceGuard, a program that utilizes a collection of telescopes to scan the skies for potentially hazardous asteroids.
We've come to realize that the Earth is, in fact, running around the sun in this shooting gallery of near-Earth objects.
Near-Earth objects, called NEOs for short, are asteroids or comets that have been slowly moved by gravity out of the asteroid belt. Their new orbit brings them within 30 million miles of Earth, a third the distance from the Earth to the Sun. Astronomers predict there are 1,200 NEOs a half-mile wide or larger, and hundreds of thousands of smaller ones.
Well, we think there's about 260,000 objects larger than a football field.
A football field-sized asteroid would wipe out a city. But with limited resources, SpaceGuard's focus right now is on the ones that would cause a global catastrophe.
The goal of the SpaceGuard project is to identify at least 90% of the 1 kilometer or larger objects
that may potentially threaten the Earth.
That leaves 10%, or nearly 120 large asteroids that may not be identified by the end of the project in 2009. To date, there are just 7 telescopes searching the night sky for NEOs. They are strategically positioned across the globe, 5 on the mainland of the US, 1 in Hawaii, and 1 in Australia.
All the surveys working together cover the whole observable sky about now twice a month.
At the Catalina Observatory outside Tucson, Arizona, astronomer Stephen Larson and his colleagues use an asteroid's motion to find NEOs.
The most common technique is to image a field multiple times and compare the fields for objects whose positions are moving or changing.
Images of the same part of the sky are taken 10 minutes apart. Then, by animating these images, astronomers can identify an asteroid.
This is a near-Earth asteroid that was discovered yesterday by our other Schmidt telescope. It's a pretty bright, fast-moving object. It's maybe half a kilometer, I think. It's an Earth crosser.
Despite this rather simple form of surveillance, night after night, astronomers are cataloging dozens of new asteroids.
Here's one now. It's got slightly unusual motion, but it's pretty faint, not identified. It's probably never been seen before.
To date, 3 NEOs have created concern for astronomers. 2 of them may intersect the Earth's orbit at the beginning of the next century. The third one, nicknamed Apophis, poses a much greater threat.
We did a quick orbit determination and noted that it's going to make a very close Earth approach on April 13th, Friday the 13th, in 2029. In fact, it's going to get within 5 Earth radii of the Earth's surface, which is actually below the altitude of our geosynchronous communication satellites. So it's going to be one of the closest near misses on record.
5 Earth radii is 20,000 miles, just 1/6 the distance to the Moon. Astronomers are confident it will miss the Earth in 2029, but that's not the real risk. If Apophis passes through a tiny portion of space called a keyhole, its orbit could be changed, with devastating results.
When it makes its close approach to the Earth in 2029, should it pass within a 600-meter-sized keyhole in space, then it will come around 5 times and then hit the Earth in 2036.
The likelihood of Apophis threading the needle of this keyhole is very small, but if it were to hit, it would be catastrophic.
Apophis is thought to be about 320 meters in extent, a little over 3 times the size of a football field. If it were to hit the Earth, it would be a big problem. It would be an explosion with far more energy than any nuclear armament we have.
Since 1995, of the estimated large near-Earth objects thought to exist, 800 have been discovered.
What I am worried about are the 300 or 400 objects I haven't even found yet. I cannot guarantee you that one of them will drop out of the sky tomorrow.
The problem is the SpaceGuard methodology is far from perfect.
The near-Earth asteroids that are swarming around the Earth, we find them kind of by chance. Just a matter of luck, whether a particular asteroid happens to be close enough when the telescope's pointed in that direction that it's bright enough to be detected by these relatively small telescopes.
And the telescopes may have blind spots. The asteroids spotted by SpaceGuard are visible due to the reflection of sunlight as they circle the Earth. But certain orbits can hide an asteroid until the very last moment.
You can imagine an object that was fairly good size sneaking up and getting on an Earth-threatening trajectory, perhaps coming out of the sun, so you couldn't see it just before it hit.
Most of the time, these hidden asteroids are small, and the friction with our atmosphere tears them apart.
We're actually fortunate to be living on the Earth because we are enveloped in this wonderful atmosphere. This atmosphere actually protects us from most of the impact events that actually involve the Earth. Impacting asteroids and comets actually are destroyed as they try to punch through or penetrate the Earth's atmosphere.
The real danger comes from those asteroids large enough or strong enough to blast through the Earth's atmosphere. The 6-mile dinosaur killer was made of stone and made it through due to its immense size. The one which created America's most famous crater, Meteor Crater, was tiny by comparison, but much tougher.
This is the world's best preserved, most pristine impact site. It's an immense crater, a 3/4 of a mile, stretching from rim to rim. An iron asteroid 10 to 50 yards across came hurtling out of the sky. When that object hit the surface, it burrowed down a distance of about the same depth as its diameter.
50 yards is a relatively small asteroid, yet because it was made of iron, its impact proved to be enormous.
It created an immense explosion which actually excavated this immense bowl-shaped cavity, throwing 175 million metric tons of rock on the surrounding landscape.
This material, now up on the rim of the crater, used to be far below me. The explosive energy of the impact event excavated this block up out of the crater and deposited up here on the rim.
The explosion was equal to the power of 1,000 Hiroshima bombs.
If an iron asteroid the same size as the one that produced Meteor Crater were to hit the Earth, it has the explosive energy, the capacity to completely destroy a modern city. It might not destroy a city as large as Los Angeles, but it certainly has the capacity to destroy a more moderate-sized city like Kansas City.
The meteor that created this crater was made of iron. A similar-sized asteroid made of stone, on the other hand, is more likely to fragment and would explode before hitting the Earth. Yet that doesn't mean it wouldn't create a catastrophe, like the asteroid that exploded in 1908 over the Siberian region of Tunguska.
It was tens of meters in size, maybe half the size of a football field. It blew up about 8 miles above the ground with an energy of tens of megatons. It was like a large nuclear weapon. Blew down a whole forest, left nothing on the ground. No crater, totally pulverized itself.
When scientists explored the blast zone, they found 1,200 square miles of destruction, slightly less than the state of Rhode Island. This from an asteroid that never hit the ground. An asteroid's devastation is etched clearly in our past. But what about future encounters? What if a huge asteroid were approaching the Earth today? It's a worst-case scenario. Millions could die. What if sometime in the future an impending asteroid impact threatened millions of lives? A mission to protect the planet from another catastrophic impact would have to be put in motion.
It's one of the few examples of natural disasters which are entirely preventable, and we have it in our power to actually do that.
We're actually doing something about the near-Earth object threat, unlike the dinosaurs, who didn't have a space program, and they checked out early.
If we find an asteroid that's headed our way, with a little planning, we'd be able to push the asteroid just a little bit so it wouldn't hit.
Scientists have devised various methods for preventing a collision. Most try to gently nudge the asteroid from its impacting orbit, but not all. The most common suggestion is a nuclear bomb.
That's a brute force method. It could potentially work. But if you're not entirely successful, you may only partially destroy it. Or you may blow it apart into a whole bunch of small debris, so now rather than a single impactor hitting you, you've got a whole spray of buckshot coming at you.
Instead of a nuclear bomb, some scientists suggest a technique using the Yarkovsky effect, a phenomenon similar to the way light causes this toy to spin.
When you have a spinning body, the sunlight impinges on the body, but then the rotation carries the heat around, and the heat is radiated off in a different direction. You could use this effect, actually, to push on the asteroid. If you were to paint it white on one side and black on another, it's not going to reflect the light the same way that it did originally.
The force of this radiated heat will slowly change the asteroid's rotation and its orbit, moving it away from an impact with Earth.
I personally think that while this was an elegant piece of physics, I don't see the practicality of hauling up huge buckets of paint to paint the asteroid. I don't think it's going to be our solution for moving asteroids unless there's great technological advances in painting.
Perhaps a more practical approach is a solar mirror. Drifting alongside the asteroid, a mirror can reflect a pinpoint of sunlight, heating water trapped in the stone, causing it to boil.
That boiling off water acts like a little artificial cometary jet, if you will. It's like a little rocket motor that over time will also change and move the asteroid's orbit to, again, potentially make it miss the Earth.
The sun's energy can be harnessed with a sail as well. Large, lightweight solar collectors can be attached to an asteroid. Then, like a gentle solar wind, sunlight can push the collectors, moving the asteroid out of its collision course with the Earth.
There are ideas of using a low-thrust propulsion device like a plasma engine to push on the asteroid or pull on it for a year or several years.
The ones that were mentioned years ago are mass drivers, where you sit a machine on the surface of the asteroid and use electrostatic charges to throw rocks off one side, and that introduces a thrust onto the asteroid.
Another very elegant solution has recently been discussed by astronauts Ed Lu and Stan Love. Their idea is essentially, if you will, a gravitational tractor. Imagine a spacecraft like this, maybe weighing 20 tons, maybe 30 meters across. Imagine parking near maybe a 200-meter diameter asteroid. The gravity of the asteroid will want to slowly draw the spacecraft in toward it. Using your thrusters on the end of the spacecraft, you prevent that from happening. Rather than falling in toward the asteroid, we now hover above the asteroid, pulling the asteroid along with the spacecraft.
The beauty of the tractor is it uses gravity to pull the asteroid out of its orbit without ever touching it. The deployment of the tractor, like all these techniques, would take years.
I always say that there's three important things when dealing with near-Earth asteroids as threats. You've got to find them early, you've got to find them early, and you've got to find them early. Because then we have the technology to deal with them, and it's not a problem. We would need at least 10, 20, maybe 30 years in advance to mount an effective mitigation campaign.
Just as important as having sufficient warning is knowing the makeup of the target asteroid.
To actually prevent an asteroid from hitting the surface of the Earth, we have to know two general things. We have to know what it's made of, what its composition is. We also have to understand the strength of the object.
Here on Earth, George Flynn and Dan Durda are testing an asteroid's strength using meteorites, fragments of asteroids that have reached the Earth's surface.
We have here a sample of an ordinary chondrite meteorite, which is one of the more common stony meteorites that falls on the planet. I'll put a little leader string on it to keep it from rotating. It won't actually affect the impact experiment in any way.
They're using NASA's vertical gun range to determine how meteorites react during collisions.
We're going to orient it so it hits on this face right there.
In this vacuum chamber, tiny metallic pellets are shot at meteorite targets at 1,100 miles per hour. The scattering of impact debris is measured, and the data is used to determine the strength of the rock. The preliminary results prove these rocky asteroids to be about twice as strong as volcanic rocks on Earth, strong enough to support a mass driver or solar sails.
5, 4.
To study asteroids firsthand in space, the U.S. launched the probe called NEAR.
We have liftoff of the Delta rocket carrying the NEAR spacecraft bound for the asteroid Eros.
In 1999, after a 3-year journey, NEAR rendezvoused with a 21-mile-long asteroid named Eros, giving us our first close-up look at an asteroid. It was made of solid rock, similar to the ones used in the collision experiments, and covered with a thin layer of dust. These were the results scientists expected. But then, in 2006, the Japanese probe Hayabusa rendezvoused with a small nearby asteroid called Itokawa. The results were startling.
Hayabusa raised more questions than it answered. We thought small asteroids would be fairly smooth. They wouldn't have much in terms of surface rubble, or regolith as we call it. Well, that turned out to be all wrong. When we got there, the spacecraft showed images of the surface at high resolution, highest resolution we've had on any asteroid to date. and it's extremely rocky surface. The surface is covered with loose, rubbly material. There was no obvious impact craters.
Hayabusa has forced astronomers to rethink their plans to deflect an incoming asteroid. Other than the gravity tractor, many of the proposed techniques would not work on a rubble pile like Itokawa.
Mother Nature has a way of pulling the rug out from under our best theories and saying, back to the drawing boards, boys.
It appears each asteroid, depending on its composition, will require its own mitigation technique, and all will demand plenty of advanced warning. But if time were short, there'd likely be no way to prevent a catastrophic impact. The only recourse is to begin massive evacuations, build shelters, ration food and water, and stockpile meat and grains. Then hope it's enough when the moment of impact arrives. Now, using historical records and the latest in computer technology, you will witness the living hell when a killer asteroid strikes. It would be a 1 in a million chance, a mile-wide asteroid hidden by the sun slipping through SpaceGuard's net of telescopes. If it were to happen, we might only have a week before it hits the Earth. Now, the latest scientific information combined with lessons learned from past impacts put us on the front lines to witness the terror and devastation if an asteroid hit off the coast of Southern California.
The horror of that event would be, I think, beyond anything that people have ever experienced in historical times.
Like New Orleans in the path of Katrina, the entire population of Southern California from Santa Barbara to San Diego must flee the oncoming disaster. In Los Angeles, more than 6 million people pile onto 3 major highways, bringing traffic to a standstill. Tent cities are set up across the deserts. No one is saying it, but everyone knows these temporary shelters may not be temporary. As the last of the population try to leave the city, the impending doom can be spotted by the naked eye.
Our first indication, just standing outside and looking up in the sky, for several nights before the impact, this object would grow from being simply one of the background stars in the sky, being brighter and brighter. Within a day or two before the impact, it would be the brightest star in the sky.
Headed for the coast of Los Angeles, it ignites as it slams into the atmosphere.
The fireball created as the object just approaches the surface and begins to vaporize and break apart, that fireball is going to be something like 25 miles in diameter. And viewed from, 130 miles away.
The fireball would be so hot, it would be hotter than tens of suns glowing at you.
It hits the ocean at nearly 30,000 miles per hour.
Water there is about 3,000 meters deep, about a mile deep. And it would basically blow away that water in a fraction of a second, make a hole in the ocean that's about 20 miles across. So we'd basically blow all that water away. It would blow all the way to the seafloor, and it would dig into the seafloor another 5 or 6 kilometers more.
Then comes the heat wave from the explosion.
It would be catastrophic. It'd be at least 1 million megatons of equivalent energy, far larger than a total nuclear arsenal.
Anything flammable spontaneously ignites. Buildings, vegetation, and people suffer serious burns.
I have humans getting second-degree burns out to at least 180 miles.
The entire area between San Diego and Santa Barbara, and from the shore near Los Angeles inland past Pasadena, everything flammable would catch on fire.
All this devastation occurs within the first few seconds after the impact. Then, earthquakes started by the asteroid's collision with the seafloor begin.
And you would feel the seismic shaking. It would be equivalent to a magnitude 8 earthquake. It would be pretty serious shaking. It wouldn't destroy big buildings, but it would shake, rattle, and roll wood frame houses.
There will be a blast of high-pressure air being blown away from the impact itself.
Winds reach 300 miles per hour.
Buildings would actually collapse, brick walls would be blown in, windows would be shattered.
The winds subside in a few minutes, but then the debris begins to fall.
The formation of that crater, a huge amount of water would have been ejected into the Earth's atmosphere, and that would have come crashing back down onto the ocean surface around it, out to distances of another 12, 13, or 14 miles.
The entire coast of Southern California is inundated with millions of gallons of seawater.
About 2 or 3 minutes after the impact itself, we would start to be showered by a fusillade of gravel. That fusillade of gravel itself would be enough to kill you.
Within 10 minutes, Los Angeles is obliterated. Santa Monica, Hollywood, Malibu are all turned to dust. And as if this weren't enough.
So you get hit by big tsunami waves about a half hour later. Tsunami waves might be gigantic. They're hard to believe, even 200 meters high. So we're talking 10-story buildings, more than that, way more than that. And it wouldn't be just one, there would be dozens and dozens of those waves. They would run in 5 miles. If you survived all the first things, you'd be washed away by those. So it's pretty horrific. We're talking serious stuff here. And the Indonesian tsunami made waves in the middle of the ocean of about 1 meter. We're talking waves in the middle of the ocean of 200 meters or so. It would be really quite huge.
And these tsunamis reach every corner of the Pacific, 150 feet high as they hit Hawaii, 90 feet in Japan. Then the largest forest fire in California history begins. The Chicxulub impact tells us that smaller debris fall back to Earth, raising the atmospheric temperatures, turning it into an oven. Within minutes, the skies over Southern California turn red with burning debris, igniting fires across the landscape. Soon, most of Southern California is ablaze. Prevailing winds push the burning embers of what was Los Angeles toward the east, starting fires in Utah, Arizona, and north to Oregon. And like the dinosaur killer, a huge cloud of sulfur combines with the smoke of the fires and moves across the western hemisphere, darkening the sky into a perpetual dusk. The temperature begins to fall as little sunlight reaches the ground. A continental nuclear winter has begun.
That has the capacity to dramatically alter agriculture, and agriculture, in fact, would have suffered for several years.
If people half a world away think they are safe from the impact, they are wrong. The cloud of ash reduces temperatures across the continent, bringing frosts in July, killing off crops in America's Midwest, the world's breadbasket. Without this essential food supply, a global starvation ensues for years to come.
People may survive in one part of the world, but if people in large swaths of the Earth's surface do not have food, civilization can begin to break down. That is probably the most important effect of an impact event of this sort. And given that the planet has, over 5 billion people, the loss of 1 million people or 2 million people seems actually rather low to me. It would be millions, if not hundreds of millions of people.
Hundreds of millions of people. One cosmic event. A single moment in time. It will take years for the debris cloud to disappear and the climate to recover. The human race will suffer unimaginable horrors, but will not be extinguished. Unlike the dinosaurs, our sheer numbers and technological capabilities may help us avoid their fate. Luckily, the chances of an asteroid threatening our planet are quite small. Yet, with the stakes so high, stronger telescopes and innovative research are essential to guarantee our survival of this mega disaster.